popular examples of the Lewis acid when BF3 reacts with ammonia, NH3. Which species is Lewis acid and which is Lewis base, and why? Well, go ahead and pause the video and spend a second drawing out the Lewis dot structures of both of these species and draw out the chemical equation, or what happened, the chemical reaction. Okay, I'm assuming that you've tried. So here it is. Remember, this nitrogen has a lone pair here. So what's happening? Well, it's not a Bronsted-Lowry acid-base reaction because there's no proton transfer. So we have to think about in terms of Lewis acids and bases. And this will happen. I mean, you'll see these types of problems. So obviously Bronsted-Lowry is a bit more obvious who's the acid and base. But in Lewis, it can sometimes be confusing. So let's think about what's happening. Well, this boron over here is gaining electrons. It's gaining this negative charge, and likewise, nitrogen has this lone pair, and it's donating it to the boron. So what does this boron bond formation imply about the boron? Well, I mean, it's easy to understand why this nitrogen forms a bond because it has this lone pair, and how does a bond form? Well, it's bond forms by the overlap of orbitals. But I mean, you would think that these orbitals are all filled and that there isn't a way for it to overlap. Obviously, these fluorines don't overlap with this nitrogen. Those orbitals aren't overlapping. They're full with the fluorine. So then what does that imply? It implies that the boron has an empty orbital that it can use to bond. So yeah, just take away from this is that this BF3 here is the electron acceptor, and so it is the acid, and the nitrogen is donating its electrons. And also that how does a bond form? Well, it's the overlap of orbitals. So in order to form a bond, you need to have orbitals to overlap. Okay.